Very often in science, you make a discovery that you were not looking for. In 1934, Enrico Fermi was bombarding the large nucleus of uranium with the recently discovered subatomic particle called the neutron. He knew that the uranium sample had changed in some way, but couldn't determine how.
He had wanted to see if moderated neutrons would pass through the nucleus. In 1938, this work was repeated by Otto Hahn and Lise Meitner.
So Hahn and Meitner had discovered that a captured neutron causes fission, a word they borrowed from cell biology, which described the process when cells split apart. They predicted that a chain reaction was possible, as new neutrons cause more fission, which raised the possibility of a new source of energy.
Upon fission of a single nucleus of uranium, you can see we get both barium and krypton, also called daughter nuclides, along with 3 neutrons.
An atom of uranium will rarely undergo fission without first capturing a neutron. Then where does the energy that Hahn and Meitner referred to come from? Let's look at the mass change during fission. There is a very small mass loss on fission of the nucleus. So where has this mass gone? Here we need to look at the work of Einstein. E equals mc squared. This must be the world's most famous equation and links mass with energy, where E is energy measured in joules, m is mass measured in kilograms, and c is speed of light, which is 3 × 10⁸ meters per second. On fission, about 0.1% mass loss is observed. So if 1 kilogram of uranium-235 underwent fission, the energy transfer would be E equals 0.001 kilograms times 3 × 10⁸ squared, which equals 9 × 10⁻13 joules. To get this amount of energy from burning coal, you would need to burn 2,000 tons. That's 1,000,000 times the mass of the uranium. On fission and subsequent chain reaction, a lot of energy, including gamma rays, will be released. For a chain reaction to be self-sustaining, there needs to be a minimum amount of material present. This is known as the critical mass. Below this critical mass, too many neutrons are lost from the metal surface and so take no part in the chain reaction. The discovery of nuclear fission was only the beginning of the nuclear age. It was Enrico Fermi who built the world's first nuclear reactor, named Chicago Pile 1, which went critical in late 1942, showing that a controlled chain reaction was possible. The Manhattan Project then led to the rapid development of fission bombs based on uranium and plutonium in 1945. In a fission bomb, 2 subcritical masses of uranium or plutonium are quickly pushed together using conventional high explosives, which results in an uncontrolled chain reaction with an almost instant release of huge amounts of energy as heat, light, and gamma rays. In a nuclear reactor, the controlled slow release of energy is used to heat up a closed loop of coolant, which passes to heat exchangers, which then boil water to provide steam to turn electrical generators. The output of the reactor is altered by raising or lowering the control rods in the core. These rods absorb neutrons and so determine how much fission is taking place.